Yeah, good day, viewers all over the world. It remains Lumaj. Today, we'll be talking about the subject mathematics, and under it, I'll be talking about introduction to calculus. Calculus. Under here, I'll be talking about differentiation, integration, the functional theory. Functional theory. Please don't mix my class. Please, if you have not subscribed, please do so now. Calculus, very simple. Just follow the principle. Like I told us, once you understand the principle, there is no big deal in calculus. Yeah, I will start with differentiation. Then I can't do calculus without mentioning the fathers of calculus. We have two scientists, yeah, mathematician, physicists that worked extensively on this topic, and their names. One, we have Sir Isaac Newton. Sir Isaac Newton. Aside this one, he works so much on gravity. That is the physics. Please don't miss my physics class. That is where you see me at work. For mathematics is just by the way. Don't miss my physics class. If you're a science student, you are going to enjoy science to the fullest. Just like my chemistry, you are going to enjoy it to the fullest because I'm a science person. So you have Sir Isaac Newton, then we have G.W. Leibniz. So those were the two scientists that worked extensively on the what calculus. Like I told us, I'll be picking it one after the other. Once I'm done with differentiation, I'll pick integration, the functional theory. So under differentiation, I'm not here to be writing stories. I'm going straight to the point. Here I'll be talking about the first derivative. Because here the goal of differentiation is just to find the gradient. If you're a physics student, you understand what I'm saying. Even for my life students, when we are finding the gradient of a shape like this one, now maybe I have this, I have a curve, I have a curve, and I have a line tangential to this. I want to see at every point a change. You know, if you look at this, if you look at this, let's say this is y axis and this is x axis. If I pick a point here, this point we have a certain value of y and a certain value of x. If I move further, it will be another value of y, another value of x. So we are now saying that there is what? A change in position. Once you have a little change in the value of x, if I move from here to here, it will also affect y. That is what differentiation is all about. Once there is a little small change in a function, there will be another change in another variable. So here I'll be talking about differentiation and derivative. In your textbook, you would have seen something like this: fx and fx. They may ask what's the difference between this. This is your normal equation. By the time you find the derivative, maybe they say dy dx. When you see dy dx, it does not mean fraction. It just means the after you have done the differentiation of that equation, what you have gotten, the differential, which is the derivative, is written as the y, the x. So let me just go straight to the point. Like I told us, I don't need to be wasting our time. Here, there is one thing they call it the law of power. That's the first thing you need to understand. But that we're going to be applying in all your differentiation, whether it's differentiation of sum or addition, differentiation of products, function of function, share, anyone you are doing, quotient, that is what you're going to apply. So the law of power now. If you have, let's say you have x raised to power n, x raised to power n. The rule says that what? First, multiply this power by the coefficients. Rule 1. Rule 1. Multiply the power. If you don't want to call it power, you can call it exponent. Multiply the exponent of power by the coefficients. By the coefficients. If you have been following my math class, knowing coefficients shouldn't be a problem. Coefficient is any number standing beside an alphabet. Any number standing beside an alphabet is called coefficient. So like I said, multiply the power. What is the power? N by the coefficient. In this case now, you cannot see the coefficient. When you don't see anything written beside an alphabet, it is 1. But let me just use a representation so that you can understand. Let's assume that the coefficient is A. This A can be 2, it can be 3, it can be 4. It's because it is 1 that if I put A to be equal to 1, you won't be able to see it. You just make 1 times this, it will just be 1. Then it will be x raised to power n. But I wanted to see it physically. That's why I'm trying to put A. Assuming A has greater value than 1. So for you to differentiate ax raised to power n, because it's the law of power, that's the general law for differentiating any function. So it's now saying that for you to find the derivative of this, that derivative known as dy dx is equal to, the rule is multiply the power or exponent by the coefficients. What is the power? N by the coefficient, which is a. That would be what? A n s. Rule 2. Subtract 1 from the power. From the power, if you don't want to call it power, you call it exponent. Once you do that, you have done the derivative. So meaning that this one will now be what? N subtract 1. So the differential of ax raised to power n is what? An x raised to power n minus 1. It's as simple as ABC. Now, you may ask, is this the thing useful? It's very useful. Engineers, they will so much make use of what? Integration and the differentiation. That's why you look at it and say, okay, what will be the budget of this building for them to start? It's just for them to integrate the quantity of gravel or granite to the quantity of cement to the quantity of sand. By the time they do the integration, then you can tell you that, okay, we are going to need, let's say, 500 bags of cement, then 3 tippers of granite, and 3 or 2 tippers of what do you call it, of sand, just like that, without even moving anywhere. It's from here. They use the laptop. Architect do the same thing. You want to just do your integration. Okay, I want to know the minimum mixture for this quality. The same way, by the time you differentiate that integration, you have the minimum unit. That's where you apply it. Let's see some examples. Let's say I have 3s squared. Differentiate 3s squared. Question 1. Question 2. Differentiate 3s squared, or let's say 3s squared, 3s raised to power 3 minus 2x raised to power 2 plus 4x plus 3. Now they put y is equal to this, y is equal to this, or they can say fx is equal to this. So by the time you want to differentiate this fx will now turn to, let's say number 1, the differential will now be dy dx. The y dx, or f function of x, or is that you write like this or like this, is equal to, you differentiate each. Like this number 1 now, for me to differentiate this, you first multiply this power by the coefficient. If I multiply this power by the coefficient, 2 times 3 is what? 6. X raised to power 2 minus 1. Then that becomes what? 6x. So the divide the x of 3x squared is what? 6x. So simple. Look at question number 2. Let me differentiate this. So for me to find the divide dx, the divide dx is equal to 3 times 3, 9, x raised to power 3 minus 1, minus, you differentiate each, minus 2 times 2, 4. That is 4x raised to power 2 minus 1. Then you have plus 4 times 1 is 4. X raised to power 1 minus 1 plus the differential of a number is 0. But they call it constant. You can put C. The differential of a number, that's the rule. When you differentiate the number, even if you differentiate, like I said, differentiate 1 million. Differentiate 1 million. This is, if you want to find the divide the x of 1 million, it's not what? 0. The differential of a number is 0. So if I want to find the divide the x of this is now what? 9x raised to power 2. If you look at it, this raised to power 3 can be 3, 4, 5. That's a polynomial. 9x raised to power 2 minus, this is 2 minus 1, that's 1, that's 4x, plus, this is 1 minus 1, 4x raised to power 0. From the law of indices, anything raised to power 0 is what? 1. So it means that this one will not be s, this x raised to power 0 will not be 1. 1 times 4, that is 4. So you are going to have 9x squared minus 4x plus 4. So this will give 9x squared minus 4x plus 4. That's the differential of this. Very simple. Like I said, let me just solve one more question. That will now be picking each one after the other. Differential of sum, differential of function of function, chain, rule, products. Very simple. Just follow the principle. You will get there. Like I say, differentiate s raised to power half. I can even say differentiate this. If you look at this and this, they are the same thing. From the law of indices, root x, by the time you rewrite this, it means s raised to power half. This is how they will give it to you. That differentiates if they will give you the question like this. If y is equal to root x, find the y dx. To find the dy dx of this, the first thing you're going to do, the y dx is equal to, you write this as s raised to power half. Once you write this one as s raised to power half, then you cannot differentiate. So how do you differentiate? This one will now be dy dx is equal to half x raised to power half minus 1. Then you do your simple mathematics. This is half minus 1. Find the LCM. That is 2. That is 1 minus 2. That's 2. That is what? Minus half. So this one becomes what? This one becomes half x raised to power minus half. So it's as simple as A, B, C. Simple as what? A, B, C. Whatever the question you are given, just follow this principle. If you are not getting it the first time, watch the video again over and over. By the time you watch it 5, 6, 7, 8 times, you are going to get the principle. So in my next video, I'll talk about other differentials. And this one will take off to like 4, 5, 6 videos. Just make sure that you subscribe so that you don't miss any of my videos on calculus. Calculus is very simple. So subscribe. Thank you very much for watching. God bless.